Hi there, we meet again by a different topic which is language. Yes, our medium of communication used every day. In this topic, it will be divided into two parts, which are the language itself and the new insights discovered through neuroscience. At the end of part 1, you will be able to know the background study of language and able to distinguish the type of image. Language is a complex system that uses various cognitive processes. This study derived from multiple sources of speech and language impairment, a stroke patient, genetic analysis of developmental disorders, and from the brain imaging studies of normal people. There are several types of damage at certain parts of brain that are associated with language impairment. As we learned from 4.1, each part of brain has its own role and thus cause different impact according to its region of the brain. The first type of damage occurs at different regions within the left hemisphere of the brain. The damage causes different kind of language disorder or aphasia. Next is the damage at the left frontal lobe that produces broca's aphasia. It is the impairment on speech production ability that can be characterized as follows. However, they are still able to comprehend heard speech but do poorly for structurally complex speech. The third damage is at the left temporal lobe that causes an impairment of comprehending heard speech. A person with Wernicke's aphasia can be recognized through. Despite all that, they are able to understand bits of spoken utterance or isolated words. The damage at the superior temporal lobe in both hemispheres causes word deafness, where the inability to comprehend auditory speech at any level. They are but they can still hear sound and identify the emotional quality or the gender of the speaker. To sum it up, all aspects regarding to language is mainly governed by left hemisphere. Both left and right temporal lobe involves for the recognition of speech, sound, and word. Meanwhile, the speech production is strongly left dominant, comprising of frontal lobe and posterior region in left temporal lobe. The learning outcome for Part 2 is to distinguish the types of techniques used in understanding language. The understanding of language can be carried out through two methods, imaging studies and genetic studies. Each of the studies may have different outcomes depending on the parts of brain being studied. The brain imaging enables to identify the new structure involved in language, for the systems in assessing the meaning of words take place in the middle and inferior portions of temporal lobe. The sentence level comprehension, which is still being studied, is located at the anterior temporal lobe. The third part is the sensory motor circuit for speech involved in speech development. These happen at the left posterior of temporal lobe that aid in speech recognition and speech production to communicate with each other, helps to support verbal short-term memory. The technique of genetic study is supposed to impede the development of fluent speech and language. This gene inhibits the learning to make sequence of jaw and mouth movement in speech which affects spoken and written language. FOXP2 is a rare mutation of gene. The gene is said to be a special type of protein that switches on and off other genes in the brain. Any changes in gene sequence may contribute to human evolution, so further research needs to be done to identify the differences in gene between animal and human.